Okay, so let's have a look at atomic emission spectrum. This is something which is immensely useful to chemists of all stripes. So first thing we need to do is we need to be thinking about electron shells as energy levels. So as we know, electrons are attracted to the positive nucleus because they are negative. And as an electron absorbs energy, it will move away from the nucleus, but it is attracted to the nucleus, so this is not stable. The further away from the shell, the further away shells are from the nucleus, the more energy required to reach them from a lower shell. So in other words, it's easier to get this electron up to here, it's harder to get the electrons up to here. So electron shells are discrete. This means that electrons cannot exist and do not exist between energy levels. So as we've got energy going into, so this atom's been set on fire, it's being heated up, as we have energy moving in, this electron here will move up. So as the energy is input, it will move up, but it is not stable. So as the source of energy is removed, the very attractive force of the nucleus will pull that electron back down again. And as it does this, light is emitted. And this is because of the law of conservation of energy. So energy was put in to hold it up there. When the extra force is being taken away, it falls back down, but it loses the energy as it goes, and it loses that as a photon of light. Again, this is to conserve energy. So why is this useful? Basically, when an electron in an allowed energy level, state, that should be excited, not exited, falls to a lower energy, or the ground state, that excess energy is emitted as light. Big jumps release energy at this end, called UV. Small jumps lose infrared, which is over at this end, and middle-sized jumps of energy, you lose your light in here, which is in the visible spectrum. Now, the energy that an electron has is not variable. In other words, every bit of energy will every electron releases a specific quantum of energy, a parcel of energy, and this is called a quanta. And that's why it's a photon as a particle and a wave. It is a specific size. Now, as it does this, it's not able to, so it releases a specific pattern. So each electron goes up and then drops back down, releases a certain amount of light that doesn't change, and yeah. Alright, we can use this to identify atoms. For example, this one up here is clearly strontium because the bands match up. I hope that made a lot of sense. We'll get back to you. Okay, I hope that made a lot of sense. If you have any questions, put them in the comments below, and we'll get back to you as soon as we can. Thanks for watching. Bye now.